everybody. Now we have a new video with a presentation of a project of navigation with ROS. I have with me Kevin, and he's going to explain how he solved the problem and show us with the real robot how it works. So let me do, I'm going to change. So hi Kevin, are you there?
Hi.
Okay, Kevin, let me do several checks so we are sure that everything's working. Okay, Kevin, perfect. Let me sound. Can you share the screen? And
Absolutely.
Start.
Can you see my screen now?
Yes, let me check that the stream is working. Okay, fantastic. So the audience is all yours. You have 15 minutes. Have fun.
All right. So hello everyone. So today we're presenting my project for the ROS2 navigation. So for this project, I have to map. First, I have to create a map for the environment using the cartographer node, and then I will, based on that map, I will run localization algorithm in order to uh, uh, locate the robot, and we can move it around. And lastly is to navigate the robot using different type of command and path planning to avoid obstacle. So let me do a small demo first here. We have to run the code. Okay. Okay. So this is the map of the robot and the environment. So now, right now, we can just move it around and we can see how it changed in real time. Okay. Then we can use navigation to make the robot move autonomously. Ouch. So in this case, because these obstacles, they have very small cross section, so it's quite hard for the robot to detect. So sometimes it will bump into one another. Yeah, it's not that good.
Okay, great. So can you explain me a bit the task that you had and how did you solve it? And
Okay, so basically this project is divided into 3 steps. So each step will be represented by a small package. So the first thing we do is we do a mapping. So we launch the cartographer in here, and then we just move the robot around using its sensor to detect the environment, and then just build a map based on it. So this is the map that has been created, and then we save it here. And after that, we will use localization, so we can detect the rod as it's moving in the map, so we can locate where it is based on the information from the sensor. So in this case, we use the map server, use the localization algorithm, and some lifecycle management. For the path planning, so in order to make the robot to move autonomously, we have to include several different nodes. So such as the navigator, some behavior and control and planner. Yeah, that's basically it.
okay, great, great, great. So I have, let me first an applause. Okay. So thanks, Kevin. So I have several questions. Just so,
Okay.
uh, what inflation did you use for the path planning and the local path planner? So can you show me the
The
value?
inflation probably in the
Uh-huh.
I don't think I have a cost map on for this.
Okay.
Yeah, I don't think I put a cost map in here.
Okay. You didn't put the cost map. Okay. 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 I understand. Okay. Great. And the other question is the values that you used for speed. So for example, there in the controller, the speed for X, the theta, and XY, and so on. Did you change them? Did you adjust them in any ways? Did you use the values of the simulation as starting point, or what exactly did you do?
So for this part, I mostly keep them the same. Uh, Only exception is the maximum value is a bit lower than this and the same, because in real life you cannot move the robot that fast.
Uh-huh. Okay.
Yeah, and the
Okay.
rest should be the same.
Mm-hmm. Did you do this first in simulation and then you did it in the real robot, or directly in the real robot? How did you develop the code?
I did try different value and see which one is smooth. Uh, Not too slow, but not too fast.
Uh-huh.
It's
Uh-huh.
just enough.
Yeah, but
Yeah.
I was asking, did you used a simulation before this
Oh
on the
yes.
robot? Yeah. Okay. 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 And the simulation was different, at least the parameters, or did it go
Yeah, a
faster?
bit, but it's not too much. It's around 0.2.
Mm-hmm. Okay, great. So, as a suggestion, I would say that you the RViz that you have there,
Mm-hmm.
you could use a pre-configured RViz so that you don't have to go there and add stuff. And I don't know if you, because I think you just run RViz directly, right?
Yeah, so I already have a config file here.
Ah,
So
okay,
we
okay, okay.
just load it up.
Mm-hmm. Okay, it loaded the last one that you. Okay, fantastic. Okay, so I think we are done. So I congratulate for the project. The robot is moving. It doesn't find the little obstacles, but that's something that in navigation it's very difficult to work around.
Yeah.
Probably.
And yeah.
Yeah. Please.
I also think that this obstacle, because it's the cross section is so small, it's really hard for it to detect. So
Yeah.
if you put like I think a bigger one, maybe it can detect.
Yeah, but in reality, you have that problem. So, for example, if you
Yeah.
have a robot in a city, one of the things that give more problems are posts and lamps, and they are really, really small. And probably you would have to implement a vision system so that it complements on the navigation that sees things that the laser navigation standards don't. So that would be an improvement there. Okay. So I think we are done. So thanks a lot, Kevin.
Right. Thank you so much.
Yeah, thank you. And let me wrap this up. Okay, so thanks a lot for watching the video, and remember to keep pushing your ROS learning. Bye-bye.